Let's talk about some things we learn in lesson 3.6. First, you need to remember that the word theorem means things that we can prove to be true. So anything that's listed as a theorem is something that we can prove to be true. In this particular lesson, we're proving things about perpendicular lines. The first thing you need to know is that if two lines intersect to form two congruent angles that are a linear pair, then the lines must be perpendicular. This makes sense to us, right? If you have two lines that intersect each other, if the angles are congruent and they intersect to form a linear pair, which means they make 180 degrees, if these angles are congruent, they both must be 90 degrees if they're going to add up to 180 degrees. So I can see how that could be proven pretty easily. The next theorem that you need to know is that if two lines are perpendicular, then they intersect to form four right angles. So perpendicular lines create right angles. Another thing to know. The third theorem from this lesson says that if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So in other words, we have side BA and side BC. Those two sides are perpendicular to each other. So when we form two adjacent angles by dividing that into two acute angles, then those two angles must add up to 90 degrees. That's what it means to be complementary. So we have two adjacent angles. The sides are perpendicular, which means they form a right angle. And so since they form a right angle, the two angles formed must add up to 90 degrees, since right angles are 90 degrees. Most of these theorems are things that you would have automatically assumed to be true anyway, but now we're saying these are things that can definitely be proven. So here's another one that will make sense to you. If a transversal is perpendicular to one of two parallel lines, then it must also be perpendicular to the other. That makes sense to us, especially because we've already learned that if we have corresponding angles of parallel lines, then the corresponding angles are congruent. Well, these are corresponding angles. So since this is 90 degrees, its corresponding angle must also be 90 degrees because the lines are parallel to each other. And if those are 90 degrees, then we know that the lines are perpendicular, which means all of these are 90 degrees from our previous two theorems. And then the converse of that is also true. Oh, no, this isn't the converse. But this will also make sense. If we have two lines that are perpendicular to the same line, then those two lines must be parallel to each other. It's the converse of the corresponding angles postulate that makes this true. So again, we have corresponding angles that are congruent because they're both 90, because they're both perpendicular to the same line. And so therefore, the lines must be parallel. So if you have two lines that are perpendicular to the same line, those two lines must be parallel. And when you think about slopes, all of this makes sense. If M and P are perpendicular because they have opposite reciprocal slopes, and N and P are perpendicular because they have opposite reciprocal slopes, then M and N must have the same slope. So let's use that to figure out which lines must be parallel. Well, we've got perpendicular here and perpendicular here. So since P and Q are both perpendicular to S, P and Q must be parallel to each other. Similarly, we have S and T are both perpendicular to Q. Since S and T are both perpendicular to Q, S and T must be parallel to each other. But if you look at line U doesn't have any right angles shown, so we don't know that it's perpendicular to any of those lines. Therefore, we can't prove anything about line U. The last thing you need to know from this lesson is whenever we're talking about the distance from a point to a line. So if I have a line and a point that's not on the line, when I'm talking about the distance from that point to that line, I'm always talking about the perpendicular distance, right? There's multiple ways I can go from the point to the line. Lots of ways to do it. And each of these distances is different from one another. So when I'm talking about distance from a point to a line, we're referring to the perpendicular distance. It's the shortest distance from the point to the line. So in this picture, if it says find the distance from point A to line BD, it wants you to find the perpendicular distance. So if I find the distance from A to B, that is a distance from A to the line. And A to D is a distance from A to the line, but it doesn't make a right angle with the line. So that's not the distance we're looking for. We're looking for A to C. That's the shortest distance from A to the line. We know that because AC is perpendicular to that line. So I'm going to find the distance from A to C to find the distance between A and that line. We'll use the distance formula. And we end up with the square root of 32. Or 4 root 2.